In this question, we are given the equation for R, which represents the range achieved by a projectile on Earth, which is given as v squared sine of 2a divided by g, where v is the initial velocity, a is the angle at which the projectile is launched, and g is the acceleration due to gravity. And so in part A, we determine the derivative of r with respect to the angle a. So let's find this. So we find the derivative of r with respect to a, which is written as dr over dA. And this equals, I'm going to factor or just write down the constant v squared by g. Since these two are constant, we just keep this without derivating. And then we have to find the derivative of only the sine of 2a. Derivative of sine function is a cosine function. So I write cosine of 2a. And then we have to apply the chain rule to find the derivative of 2a with respect to a. And when we find the derivative of 2a with respect to a, we get 2. So we have to put this 2 as a multiplier. Now let's simplify this. And so this equals, we can write this as 2v squared by g, and then cosine of 2a. So this is the expression for the derivative of r with respect to a. Let's do part B. Here we have to determine angle A, which maximizes the range. So for this, we are going to use the first derivative and the second derivative test so that we could find a point which maximizes the range. So we find the critical point of the function r. Since we already have the first derivative, we just set this up equal to 0. That is dr by dA equal to 0. And we should find the corresponding a, or the angle, which maximizes the range. So let's find the critical point by setting up this equation. That is 2v squared by g, and then cosine of 2a, and this equals 0. Now let's multiply both sides by g and divide by 2v squared. So therefore, when we do that, we get cosine of 2a, and this equals 0. I'm going to write this 0 as a cosine of pi by 2, because cosine of pi by 2 is 0. And also this pi by 2 lies in the given interval. And we now have this equation cosine of 2a equals cosine of pi by 2. So therefore this angle, that is 2a, must be equal to pi by 2. And so this implies we divide both sides by 2. We get the value for a equals pi by 4. And this is the critical point of the function r. And now we should verify that at this point the range is maximum. For that, we have to replace the second derivative. So let's find the second derivative of r. So first, I'm going to copy the first derivative of r with respect to a, and this equals 2v squared divided by g times of cosine of 2a. Now let's find the derivative of this one, that is d2r by dA2. And so this equals, once again, this 2v squared by g is a constant. We find the derivative of cosine of 2a, which is negative of sine of 2a. And then applying the chain rule to find the derivative of 2a with respect to a. Once again, this will be 2. So we multiply with 2. So we can reduce this to, we have a negative and 2 as plus 2v squared. So this will be negative 4v squared divided by g, and then sine of 2a. Now we should plug this critical point into the second derivative and verify if it is positive or negative. That is d squared r divided by dA2. Plug in the critical point, that is a equals pi by 4. And so this equals negative 4 times of v squared by g. sine of 2 times of replace a by pi by 4, so it becomes like this. And so this gives negative 4v squared over g, and then times of sine of pi by 2, because we can cancel this. And we know this sine pi by 2 value is 1, so therefore this is going to be negative 4v squared divided by g times 1. And so this equals negative of 4v squared divided by g. And this is going to be a negative quantity. Since it is negative, that is the second derivative d2 r by dA2 at the critical point a equals pi by 4. This is negative quantity. We see that at this critical point the range is maximum. At a equals pi by 4. So we have determined that at a equals pi by 4, the range is maximum. And this answers the part B question.